talk interruptions.
Always messes up.
Okay, this is page 57, because 56 was the Unit 4 cover page. So this is 57. We will fold it and glue it to a sheet of notebook paper in just a little bit. Before we dive into this sheet, I need you to recall. Recording of the video. I need you to recall this. Do y'all remember this?
Yeah.
Okay. Do you remember we learned translation, reflection, rotation? Do you remember we said there's another one called dilation, but we're not going to do it yet?
Yes.
But now we're doing it. Do you remember why I said we're not dilating yet?
Because doesn't it be confusing?
It's getting like bigger and not moving. Like those are moving and that's like.
So, translate, reflect, rotate were what's called isometric or rigid transformations, which meant the shape was just moving. It's kind of like taking a cookie cutter and just moving the cookie cutter. Whereas a dilation means the shape is actually changing size. It's either going to get bigger or it's going to get smaller. When you go to the eye doctor and get your eyes dilated, your pupil gets bigger so they can see in the back of your eye. A lot of people think dilate means get bigger. When you step outside and the sun is really bright, your eyes dilate to get super tiny so that your eyes don't get hurt by letting too much light in, right?
You drop when your eyes are dilated big.
It's not safe to drive with dilated eyes.
But like, let's say,
usually they ask you to have someone drive you away from the appointment.
I drove my grandmother to her eye doctor one time.
What's the problem with driving with dilated eyes is things are super, super blurry, which welcome to anyone's world of glasses or contacts. That's how we feel all the time. But with dilated eyes, it's also unsafe that you've just left the doctor's appointment. They dilated your eyes. If you were to get in a wreck, that's a liability on your half. So.
I'm supposed to wear glasses.
Okay, shh, I'm losing you. So we're going to start our new unit with dilations, and they tend to be one of those units or one of those lessons that people like because they get it. Okay, so I hope that's the case with you today. Your flip book is covering the only two possible types of dilations. You have what's called a reduction, or you have what's called an enlargement. It's getting smaller, it's getting bigger. Okay? How do we rate? How do we talk about the size that it's increasing by or the size that it's decreasing by? We use what's called scale factor. Scale factor, you've heard before?
Yeah, that sounds familiar.
If you think about Hot Wheels cars are a scale factor model of the actual car, right? They've taken an actual car and they have shrunk it down to like a 3-inch little toy, okay? And it's by a scale factor. If the scale factor, let me back up. You see how there's the letter K here?
Yes, ma'am.
Okay. Do you remember slope? What letter was represented by slope? M. Everybody with me?
Yeah.
Okay. Scale factor is represented by the letter K.
Yeah.
Don't ask me why, but it is. But K stands for scale factor. If the scale factor is less than 1, that's how you read this. Less than 1 means it's getting smaller, it's shrinking, it's a reduction. If the scale factor is greater than 1, it's getting bigger. Take this triangle right here. I want you to label the points of A, B, C. Then we are going to use the scale factor to find the points of A prime, B prime, and C prime. So read the graph, find the coordinates for A, B, and C, and write them down. Hopefully you remember how to read coordinate points. Remember your first number is right or left. Your second number is up or down. So A is what coordinate points? Very good. B?
-3, -3.
Very good.
+3, -3.
Very good.
Let's go, Easton. Yes.
All right, now we're ready to dilate this triangle by a scale factor of 1/3. So this is where I was saying you're going to need a calculator because some people do not like working with fractions. That's okay. We're going to type it in the calculator. We're going to let the calculator deal with the fractions. How do you dilate pre-images? You are going to multiply the scale factor by the individual coordinate points. So you're going to get k times x and k times y. So go to your calculator. We're going to look at A. You with me? Let me pull mine up.
Hey, I've got some polyroot find or something on my calculator right now.
Hit, clear.
I did. Hold on, there's an exit button down here.
It won't go to it.
But it won't, hey, there's an exit button, but it won't go to it.
Hit second, quit.
Second, quit.
All right. Okay. Watch how to enter this. So all you have to do is multiply the scale factor by the x and the scale factor by the y. Okay, so we're going to fix A and we're going to find A prime. So I'm going to multiply -3 times, what's the scale factor? 1/3. Here's how I type fractions in the calculator. Alpha, with me? Alpha, y equals,
Bravo.
and it's that very first option, n/d, that means numerator over denominator. Hit enter. And then it will appear in math print mode, so you can actually type a 1, arrow down, type a 3, hit enter.
Is it -1 and 1?
Yes.
It's like -3 and then
Times alpha y equals. Y equals. There you go.
Where's y equals that?
Top left.
I didn't get to the
Why did
bottom.
it make an R? It made an R.
You have to email.
Wait, and then do 1
Email.
and
You have to.
Wait, what number do we use now?
This
1?
computer's so
You
complicated.
got to get used to it.
You
That's
said-
why I want you to start practicing with it.
Okay, so -1.
So we got -1. Now, if I multiply 3 times 1/3, what am I going to get?
1.
1. Now you're going to repeat with the remaining points. Find B prime. Yeah, you really You're going to find B prime and C prime. And then I want you to go to your picture and I want you to graph it. Can you practice typing it in the calculator with your other hand?
This hand?
Your other.
The other one. Why would she ask you to type it in there with the broken one? Sorry, I'm swerving because that was really dumb. What?
Practice typing it in so that when you take the quiz, you're not, because you're going to have to take it, like on your own. So I'm looking at you. Oh.
I did.
All right. Did y'all find B prime and C prime?
Did you
Yes.
put your phone
I'm
in there?
grabbing it right now.
I don't think that you put your phone in there. Because I see it in your pocket.
It's not in my pocket.
That's all it is.
Do you want to pat me down?
I'm not in the
That's
business
kind
of
of a weird
patting
question.
people down.
I'd rather
That's not my.
I'm not like
Right? Don't start today.
Shy's not following rules.
What does she do?
That's not my name.
Shy? That is her name.
Cheyenne.
Please don't forget that I am
Cheyenne.
recording.
Oh yeah.
Oh.
Okay, did you draw the triangle?
Can they hear us?
Yes.
Can I hear
Sorry, guys.
Yeah, they can hear
What'd you get for B prime?
Negative 1 and negative 1.
Let's go.
And what'd you
Beth,
get for C
Beth.
prime?
1 and negative 1.
Yes, Beth.
So let's graph it. So we got negative 1, 1 is A prime. Negative 1 is B prime. And 1, negative 1 is C prime.
I'm so down for that.
Now I would like you to do the
Next one.
next one. There's no reason for us to go practice shrinking. They're the exact same concept as the enlargements. It's the same thing. So please do the enlargement example that's at the bottom.
Do you care to go over it one more time?
Oh, that's what you get to using in the middle of the example. Time for you to get a what? We got 20 minutes, buddy. Get
I
locked
need to
in.
get that roll up.
Yeah.
Oh, yeah, but over that one.
You're just multiplying. You're going to multiply k times x and k times y to get the points. So k and then times x, k times y, and then you write it down. Then you repeat.
So you're doing 1/3
Times 3.
and then 1/3 times
Negative 3. Or whatever it is.
Yeah.
Yeah.
right.
Yeah. And to type the 1/3 in the calculator, do alpha
I
y
didn't mean
equals.
Minute, you want me to pause them?
That was an example of a reduction, right? Will you take your AirPod out if you don't mind?
That's going to be on the recording.
That was an example of a reduction. Now let's do an example of an enlargement. That just means that the scale factor is a number bigger than 1. So the way you would talk about this shape, you would say that it is going to get 3 times as large as its pre-image. Let's write the coordinates of D, E, F, and then let's find the coordinates for D prime, E prime, F prime. So what's the coordinates of D?
Negative 1,
and
1.
Negative 1 and negative 1.
And F.
1 and negative 1.
Positive 1 and negative 1.
Now, you should be able to do this one in your head. I hope you don't rely on the calculator when multiplying by a 1 or a
I
negative
do,
1.
but that's because I get scared.
Well, let's build some confidence in you. You can do it. We are tripling the size. We're tripling it. So D prime should become what?
Negative 3 positive 3. Okay, Betty, you're too.
Add a baby. You don't have to. You don't have to participate.
Don't call her
anymore.
baby. You only call me baby.
Negative 3, negative 3.
Very good. And then one more new person.
I got
Thank
it.
3, negative
3,
3.
negative 3.
He's in your life.
And then now you would graph this.
I already graphed it.
Right. You got to keep your hands.
Really?
I'm doing this one. Don't worry, this one.
What just happened?
Oh, look! You made it for expired for the first time forever.
Well, you have 2 seconds to close it. Nope.
Wait, I don't think I closed mine.
Oh, guys, we're carrying plants in the hallways.
Look at the pictures.
All right. Now please open up your flip book. You have 4 practice problems. Let me give you a little guidance on 3 of them. Actually, excuse me, all 4 of them. Okay,
Why? I don't want
let me show you what's going to
They
happen.
have fractions.
They have fractions. When you go to multiply by these scale factors, you're going to get answers that have decimals, okay? Right?
Right.
You're going to get answers that have decimals. You need to think about how to graph decimals. Remember, half means just go halfway, right? 0.25, that's a quarter, which means just go a little bit past where you're at. Let's do this one together. What is this? I guess we'll call it number 1. Let's do this one right here, where the scale factor is 1/2. Now, I have a question. Let's think of a smarter, not harder way to, y'all try to keep your feet off the couch. Let's think of a smarter, not harder way to multiply by 1/2.
Just do by, just add it, add that.
I said that. So that's fine.
It's just cut in half. I'm just gonna keep one.
There you go. What is the same thing as multiplying by 1/2?
Divide by 2.
You're correct. What I was going for is what's another way to write a half?
0.5.
Thank you. That's it. That's what I was going for. Some people struggle trying to get the fractions
I
in.
wonder why.
If you change it to a pretty decimal, if it's pretty, now 1/3 was not pretty, right? 1/3 is 0.3 repeated. I would not recommend typing that in as a decimal because then you would be cutting off value and then you're going to mess up your answer.
For 1/3, you're not pretty.
Guys,
I didn't like that way, so I know you
I'm trying to get a phosphor passive, not the peanut.
okay, well, look. Did you really? Do you not have signal?
Yeah, he was trying.
Point it to her forehead. It always works for me.
Look right there. No, Easton asked first. He's got E, I promise.
Yeah, that's why I'm just waiting until the bell rings.
Well, Easton.
So you're filling in A, B, and C in this picture. Well, remember what I said, 1/2 as a decimal is actually pretty. So this would be there's a faster way to multiply. If we wrote 1/2 as what?
0.5
There
and
you
also
go.
divided by 2.
There you go. Hold the divide by 2 to yourself, but I see what you're doing and that's fine. In the past, I've tried to show that shortcut and I lost people more than I,
You want to know why this Holcombe?
huh?
You're the R word.
1.5 and
That's not gonna happen.
Is it okay?
No. Yes, ma'am. You're the
Oh,
S
yeah.
word.
It's gonna be,
Stupid.
so it is going to kind of be floating and that's fine. It is a decimal.
Okay, so you want to start in decimal.
Right, because when you go to graph, you need it in decimal form. You don't
Why
know
is
how to
it
graph
running
a
right now?
fraction.
This Holcombe, this calculator is broken.
To graph, we need it in decimal form because we need to know like I can't graph 3/2, but I can graph 1.5.
But I don't
Those are the
understand.
same thing. So
Just divide it by 2. Whatever answer
you're
you get, divide by 2.
multiplying all of these numbers by 0.5.
That's
That's
What
what
you
you're
were
gonna
doing
write.
with the 1/3 is the exact same thing you did with the 1/3 with this.
It would be halfway between
And
-1
when you get a
and -2.
fraction, write it as decimal.
It's
So you're gonna
negative
get
1.5.
2, which is 1.5. But how am I gonna get 1.5 and plot 1.5? You're gonna
You're gonna go
over one,
halfway.
half.
I got you. If you'll just wait a second.
0.5 times -3. And then I get -1.5.
Right.
Look, Rich looks like right there.
And then 4 times 0.5. So when I graph A prime, I'm going to go left 1 and then halfway to the next point. Then I'm going to go down 2 and it puts it right there. So it is floating, which feels off.
Wait, what number is that?
First one.
A?
A.
Is it not plus 2?
Oh, yeah. Thank you. Go left 1.5, and then I'm gonna go up 2. I'm sorry.
No, it made me feel dumb for a second.
Sorry.
I was like, 4 divided by 2 is 2.
4 divided by 2. Come on.
Thanks. That one's in like the middle of the whole box. B prime's like in the middle of a box. 'Cause
Yeah,
it's
I think
negative half,
so.
negative half.
So it'd be -1/2, -1.5. So I'm gonna go left 1 and then halfway, down 1, but then halfway. That's why I graphed that there earlier. C would be 1 and -1.5, right?
Yes.
Now, question, what if I graph mine and I end up like this?
Oh, you did something wrong.
That's tough.
You did something wrong.
You should know that these dilations
It's wrong.
should line up within the same area of the pre-image,
Yeah, it should be like
and
the same thing.
you should be able to determine it's the exact same shape. It's just a different size. Should have the same orientation, which means how it's turned. Everything should be the same. Now, I will say when you go over to the next problem, which is on the right, it's 3/4. What decimal does 3/4? 0.75.
Yeah, 75, gang.
So it's going to be easier to multiply by 0.75 here instead of 3 divided 4. You're going to get, oh yeah, you'll still get the same answer. I'm just saying if you didn't want to do the fraction. You are going to get some numbers with a 0.25 decimal. 0.25 is really hard to plot. So you're just going to go just past. Like for instance, if I was trying to graph, let's say right here. Direct your attention here. Let's say I was going to graph up 2.25. If I go up 1, 2, 0.25, you just kind of put it just a little bit past it. Okay, you need to finish these 3 examples.